Hi. Today I'm going to be virtually solving Educational Codeforces round 146, Div 2. I hope to do C and then B and then E. Let's see how this goes. I get 45 minutes for C for thinking. C, it started. Suppose you have n boxes. The ith box contains infinitely many balls of color I. Suppose you need to get a ball with some specific color, but you're too lazy to do it yourself. Okay. You have two robots to, is it like, okay. Two robots to retrieve balls for you. You have to program them. Have to construct two lists where the list A represents the boxes side. Okay. Enter in one of these lists. Okay. Okay, suppose S1 is 2 and S2 is 3 is 4, 1, 5, 3, 7, 2, 6. So you have to partition them. You request a ball with color 3. The following happens. Okay. You know that you're going to request a ball of color 1 R1 times and a ball of color 2 R2 times and so on. I want to construct the lists A and B for the robots in such a way that the total search time for all requests is minimum. I see. Let's look at an example. Three integers n, s1, s2, say 7, 3, 1. Oh, the number of times you will need each color, 8, 6, 4, 4, 4, 1, 7. Wow, this looks complicated. What are the things to think of here? Okay. So the first robot is going to take 3 seconds for everything. The second robot's going to take 1 second for everything. You're going to be requesting ball 1 8 times, ball 2 6 times, ball 3 4 times, and so on. 3 4 5 4 4 times, and then 6 ball 6 1 time, balls 7 times. I see. So you can't even be greedy about it, I think. Like, for instance, if I'm looking at here and thinking, I want to place it all such that ball one gets the least search time because I'm calling it 8 times. Because I'm going to do it 8 times, but the issue might be could have had a better arrangement, which has maybe the second least search time for this, but the least search time for something else, and it works out better. Let's just randomly partition for now. How long does ball one take? Oh no. Let's say 1, 2, 3, 4. One issue is when I see questions like this, I've already started believing I can't solve them. So I need to start believing that this is an easy question that I can solve. Oh. Hmm. Okay, so I'm thinking, okay, when the first ball's here, takes a total of 8 seconds to search for it. So really, I mean, I want to put 1 here, and then I want to put 7. Um, then maybe I want to put 2, but I would have put that in either. Um, takes 4 seconds. 3, 4, 5. Would take 5 seconds. Maybe this is how I would arrange them. So why did I do this? I did this because so 8 is called the most, so 1 is called 8 times. So that would be a total of 8 seconds. 7 is called 7 times. So that's a total of 14 seconds. 2 is called 6 times. 18 seconds. Oh, right. Yeah. Both the robots are independently searching. It like they're not like waiting for each other or anything. So that's a pretty good thing. Right. So the search time. hmm, So at the end of the day, all you need to do is you have S1 and S2. Um, and you have these guys R0, R1, R2, and so on, Rn. So you get to place all of these in here, and you get to do something times S1 plus something times S2 plus something times S1 plus something times 2S1 plus something times 3S1 and so on. Plus something times S2 plus something times 2S2 plus something times 3S2 and so on. It seems clear to me that even without picking the R's, you would just pick all the least S's, right? And then just place your R's in descending order. Right. So in this case, this list is 1, 2, 3, 4, 5, 6, 7, and so on. And this list is 3, 6, 9, 12, and so on. And I need to pick I have to pick 1, 2, 3, 4, 5, 6, 7 guys. Yeah, the seven smallest guys. So I'm gonna pick this, and this. And once I pick them, I place them in sort of ascending order, which is like maybe 1, 2, 3, 4, 5, 6. And then the first guy here. So this is the first guy, second guy, third guy, fourth guy, fifth guy, sixth guy, seventh guy. And I will just do my elements in descending order, which is the first element has 8, the seventh element has 7, the second element has 6, and then 3, 4, 5, 3, 4, 5, and then 6. And the numbers turn out to be 8, 6, 4, 4, 4, 1, 7. Right. So the total time I should be worried about is 8 plus 14 plus 18 plus 20 plus 24 plus 7 plus 16, 40, 60, 75, 75, 85, 95, 93, 103, 107, 107. It's the minimum cost. Yeah. The output print 2 lines, the list A and the list B. Each list has to be printed. Print the number of elements in it and then the elements themselves. Oh, okay. 2, 5, 6. Okay, 2 and 5. So what they did was 1, 7. Yeah, I guess pretty much the same thing. 1, 7, 2, 4, 3, and 3 and 4 and 5 you could switch around. Yeah, so that should be fine. And yeah, that seems to be okay. Okay. By 1 and 10, and you're calling them all just once. 0 elements. Oh, 5 elements, 4. Yeah, makes sense. Okay, then 8 elements, both are 1 and 1. So I guess 1, 2, 3, 4, 1, 2, 3, 4. Makes sense. Okay. So what is the nicest way to do this? I think okay. So sort the array indices in descending order, right? And keep the 2 vectors and keep like a current guy for each. the current like sort of load for each. Whichever is bigger, push into that. I think that should work. Yeah, that would be my strategy. Okay, that was fast enough. It's 20 minutes. My terminal looks small. I think I changed preferences. Ta-ta, ta-ta. Yeah. I used 24. 18 is too tiny for me. Okay. Oh, yeah. Oh, oh shit. Okay, now. VFI is equal to make their um a comma okay. Um mm, mm, um so you want to sort in descending order, right? Shit, I don't know the sort in descending order. I forgot. Okay, let's just do for in I is equal to n minus 1, I greater than equal to 0. if S1 greater than S2, dot push back P of I dot one plus equal to S1. Oh no, 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 no. That would have screwed up so badly. I hope I'm sharing the, yeah. I was about to like shoot myself in the foot. Okay. Let me just say int eval equals s1 eval equals s2 eval less than or equal to eval. Okay. S1 eval plus equal s4. Else b dot push back v apply dot second b1 plus equals this. Here a dot size a here yeah, that looks okay. All of this looks fine. And to think I thought this would be hard. Okay. A robot is placed. Oh, okay. I'm reading. Oh, it got accepted. Oh no, I didn't share that, but okay. My code got accepted. So I am now sharing the screen for B. I'm also hungry. That's okay. Okay. Und jump this cell. Oh, nice. Nice. X plus m comma y. Jump to cell x plus x comma y plus m. or increase the length of legs by 1. What is the smallest number of moves the robot has to make to reach a cell A, B? Interesting. Okay. So what am I thinking here? What is the initial length of the robot's leg? Oh, 1. Okay. What is the minimum number of moves? 0, 0 to X, Y. You have to cover X with this and Y with this. Um, Seems to me that whatever the minimum, except for like edge cases, whatever the minimum distance is between the two, you spend, oh, very interesting. Because imagine if mm, so if you spend one move increasing your leg length, okay, what I see it as is, okay, you need to do, like, if you didn't do any of this leg length increment, you would have to do X plus Y moves, right? And if you do one increment, you will be able to do it in 1 plus X by X plus Y by 2. I'll take care of edge cases, right? If you do 100 test cases, 10 to the 9. If you do 2 increments, so now your leg length is 3, then you're covering it at X plus Y by 3. Uh-huh. So it seems to me, given x plus y is a constant, you want to minimize a plus c by a. And I don't know, what is the minimum of this? Is a square root of c? Then I get 2 square root c. I think so. Because if I take the derivative, I get a plus b. I'm a bit confused because I'm doing oh, yeah, a is equal to root c. That would be like the best case scenario if yeah. But now the issue is I might not find a nice square root. And even if I do, these guys might not be divisible by that number. Let's see some examples. For instance, if you want to go to 8, 4, my instinct would be the number closest to square root, right? 8 plus 4 is 12. And I think 3 into 4. So either by 3 or by 4, can definitely do a by 4. So 4 plus 12 by 4 will 7 would be my answer. You can do it in 6. Oh, sorry. The leg length is a plus 1. In this case, it would be 3 plus 12 by 4, I see. Okay, so that is fine. But like the divisions they give might not be like, maybe I can't easily jump. So so 6 plus 1, 7. Um, I'm so hungry. Should have eaten. if I was just doing it for one axis, I would just do like what I'm saying right now. Okay. But if I have both, there's something I'm missing. Is it? It feels like you what can you approach it separately? Can you be like for the first axis this and the second axis? So suppose you know your solution for the first axis that you want to increment so and so times and then jump. You know your solution for the second axis. Okay, maybe like I'm just dreaming too much. Let me concretely like I feel like I might abandon this halfway and continue offline. Not a great idea to start. But yeah, that's okay. Yeah, actually, maybe it's best I do that. Yeah, so I will continue this, but I won't be able to post the rest. So that's just C for now.